Now we will solve the question 10. In question 10 it is asked the Hamiltonian operator for a two-state system is given by H equal to A 1 1 minus 2 2 plus 1 2 plus 2 1, where A is the number with the dimension of the energy. Find the energy eigenvalue and the corresponding energy eigencase as a linear combination of 1 and 2. Here one thing we assume that 1 and 2 are the orthonormal eigencates, orthonormal eigencates of this two-state system. And second thing we will do, that is we will represent this operator H in matrix representation. Then what will be its H11? It will be 1 H1. Since these are the orthonormal eigencase, that means only this term survive. Then what the value will be? This value of this term will be A. Now let us calculate H12, which is 1 H2. Then only this term will survive, other terms will give 0. That means here also will get A. Then let us calculate H21. H21 means only this term survive, that means we again also get A. Now let us calculate the value H22. H2 only this term survive, that means we'll get minus A. We'll get minus A. So our matrix will be, operator in terms of matrix will be A into 1 0 1 1 1 minus 1. And now we have to calculate the eigenvalue of this operator. If lambda is the eigenvalue of this operator, then H minus lambda identity, its determinant should equal to 0. That means determinant of A minus lambda A minus lambda should be 0. That means A minus of A plus lambda minus A square should be 0, which is equal to minus A square plus lambda square minus A square equal to 0. That means lambda is either plus root 2a or minus root 2a. So this Hamiltonian only has two eigenvalues, one is plus root 2a and another is minus 2a. Now let us check what is the eigenvectors corresponding to this eigenvalue. So let us assume that the eigenvector x is equal to alpha beta. Now operate, if we operate hx, we will get lambda 1, this is 1 and this is 2 into alpha beta, that means x. Let us check what it is. A 1 1 1 minus 1, and here root 2a alpha beta, operator on alpha beta will give root 2 alpha beta. That means alpha plus beta, alpha minus beta will be root 2 alpha beta. That means these two equation will hold. Alpha plus beta is equal to either root 2 alpha or alpha minus beta is equal to root 2 beta. From this equation we will get beta is equal to root 2 minus 1 into alpha. Now if we put alpha equal to 1, then we will get beta equal to root 2 minus 1. That means one eigen vector, that means x1 will be 1 root 2 minus 1. Now the what? Now let us calculate from here also. What is the value? Alpha equal to root 2 plus 1 beta. Now if we put alpha equal to 1, what will get? Beta equal to 1 by root beta plus alpha. Now what is 1 means? 1 means 2 minus 1 by root 2 plus 1. That means root 2 minus 1 into root 2 plus 1 by root 2 plus 1. That means root 2 minus 1. From this equation we also get the same x1 equal to 1 root 2 minus 1. Now let us calculate the eigenvalue corresponding to the eigenvector corresponding to the eigenvalue minus root 2a. So again, suppose the eigenvector 2 is alpha prime beta prime. If we operate this operator 1 1 1 minus 1 on this state alpha prime beta prime, it will give minus root 2a alpha prime beta prime. That means alpha prime plus beta prime, alpha prime minus beta prime is equal to minus root 2 alpha prime minus root 2 beta prime. That means alpha prime plus beta prime is equal to minus root 2 alpha prime, and alpha prime minus beta prime is equal to minus root 2 prime. So from the first equation number 1, will get beta prime is equal to minus root 2 plus 1 alpha prime. If we put alpha prime equal to 1, we will get beta prime equal to 1, beta prime equal to minus root 2 plus 1. That means the corresponding eigenvector corresponding to the eigenvalue minus root 2 will be 1 minus of root 2 plus 1. So now we can express the eigenvalue in terms of the base case, which is 1, which means 1 0, and 2 in the matrix representation, which means 0 1. In terms of this, x1 will be what is x1? X1 is 1 into 1 0 plus root 2 minus 1 into 0 1. That means x1 will be 1 plus root 2 minus 1 into 2. Similarly, x2 is 1 1 0 minus root 2 plus 1 0 1, which is, that means 1 minus root 2 plus 1 2. So these are the eigen vectors corresponding to the eigenvalue root 2a and minus root 2a of the Hamiltonian operator H. So that is that. Now we will solve the question number 11. In question number 11, it is asked a two-state system is characterized by the Hamiltonian, H equal to H1111, H2222 plus H1212 plus 21, where H12, H22 and H12 are the real numbers with the dimension of energy, and 1 and 2 are the eigenstates of some observable not equal to H. Find the energy eigenstates and the corresponding energy eigenvalue. Make sure that your answer makes good sense for H12 equal to 0. You need not to solve this problem from scratch. The following fact may be used without proof. This fact we have to use that the eigenvector corresponding to the operator s dot n cap is equal to n cap plus cos beta by 2 plus e to the power I alpha sin beta by 2 minus, where beta and alpha are the polar azimuthal angles respectively. Now, to do this problem, let us to calculate these eigenvectors of this operator by the help of these things. Let us first rewrite this Hamiltonian operator. H equal to, it is given that half H equal to it is given that H equal to H1111 plus H2222 plus H1212 plus 1. This 1 and 2 same as plus and minus gates for the spin system. These are the orthogonal state, 1 and 2 also orthogonal state. So let us rewrite these in some terms. Suppose H equal to half. You can write this H11 plus H22 times 1 plus 2 plus half H11 minus H22 1 minus 2 and this is H12 plus 2 1. Now from the completeness relation we know that this is nothing but identity operator. So let us write H minus half H11 plus H22 identity operator is equal to half H11 minus H22. This is nothing but similar to SZ operator. Suppose write SZ, and this is nothing but similar to Sx operator, that means H12 Sx. Now if this is similar to S dot n operator, then this term and this term will be, that means this term will be corresponding to nz, that means that nz, the nz component was cos beta, that is equal to H11 minus H22 pi 2, and nx is equal to H12 and ny is equal to 0. Then nx equal to here sine beta cos alpha, this will be cosine beta sine alpha. That means tan alpha is equal to 0 ny by nx, which is 0 by h12, that is actually 0. That means alpha can be 0 or pi, sine that alpha and pi. Now let us calculate beta. It means if we put the value here, we'll get if we put the value of alpha, we'll get nx is equal to h12 now tan beta is, what is the value of tan beta? Tan beta will be n x by n z. Alright, এটা কথা tan beta equal to 1.8 tan beta এটা কই now what will be the value? Now let us calculate the value of beta, which is tan beta will be root over of nx square plus ny square by nz. Here will be nx by nz, that is equal to, what is the value of nx here? h12. nz is half h11 minus h22. So that means beta will be tan inverse to h12 h11 minus h22. Then the corresponding state, eigenstate will be cos beta by 2. Cos one state will be, one state corresponding to alpha equal to 0, and other eigenstate is corresponding to alpha equal to pi. That means one state, suppose psi 1 is eigenstate of that Hamiltonian, is equal to cos beta by 2 plus e to the power I into 0 into sine beta by 2. It is plus of minus. That means one eigen vector will be cos beta by 2 plus, here beta is this, plus sine beta by 2. Another eigen vector will be psi is equal to cos beta by 2 plus of e to the power plus I pi sine beta by 2 minus, which is cos beta by 2 plus minus, since I e to the power I pi equal to -1, sine beta by 2 minus. Now it is the eigen vectors of the operator h minus half of h11 plus h12. That means psi will be some eigenvalue. I have to calculate, we have to calculate the eigenvalue psi. That means it will be h psi. Since there is identity operator, that means it will nothing but minus half h11 plus h12, which is a constant psi. That means this psi is also a eigenvectors of the Hamiltonian h, half h11 plus h22 sorry, h22 psi. Now let us calculate the eigenvalue of this h. Calculate these things. What is the matrix representation of the h? Matrix representation of the h is nothing but h11, h12, h21, h22. Then what will be its eigenvalues? That means h minus lambda I, its determinant will be 0. That means h11 minus lambda, h12, h12, h22 minus lambda is equal to 0. That means h11 minus lambda into h22 minus lambda minus h12 square is equal to 0. That will lambda square minus lambda into h11 plus h12 minus h12 square equal to 0. So the value of lambda will be plus h11 plus h22 plus minus root over of h11 plus h22 its square plus 4h12 square by 2. So this 2 is the eigenvalue corresponding to the Hamiltonian h. These two are the eigenvalue of the Hamiltonian h, and the corresponding two eigenvector will be, one will be cos beta by 2 plus sin beta by 2, and this plus actually means 1 and this minus actually means 2. So cos beta by 2. So what will be the eigenvectors? Let us write here. One psi 1 is cos beta by 2 1 plus sin beta by 2 2, another will be cos beta by 2 1 minus sin beta by 2 2. So that is asked in question 11. So we have solved the question 11.